All right, so we're going to review operators in Java here. We've got addition, subtraction, multiplication, division, and then this new one, or what's probably new, modulus. So let's talk about this for a second here. So I'm gonna type some stuff in here, and I want you to tell me what's going to spit out. We did this a little bit last class, so something easy. What's going to be the result of this operation here? When I execute this code, what's going to spit out? 3 plus 7 plus 9 should just be 19, right? And then, yeah, it is. Okay, but what if I instead put in a different operator here? 3 plus 7 times 9. What's the order of operations here? Does it do 3 plus 7 first or 7 times 9 first?
7 times 9.
Yeah, it's the same as in your algebra class. PEMDAS multiplication comes before addition. So what is 7 times 9? 67. Plus 3? 7 times 9 is 63 plus 3 is 66, right? There it is. That's what it's going to spit out. Now, what if I put in here, instead of 3 plus, I did 14 divided by. How's that going to evaluate? 14 divided by 7 times 9. What's that going to... Which one does it do first, division or multiplication? But it's PEMDAS, so I thought multiplication came before division.
It's left or right, they're the same.
When they're the same, when it's multiplication, division, it's left to right. So it's going to do that division sign first, and then it's going to multiply by 9. So 14 divided by 7 is 2. Divide by 9... 14 divided by 7 is 2 times 9 is 18. There it is. All right. Now, let's do a weird one. Get rid of some of this here. And now, I want to ask you, what's going to be the output here? 9 divided by 4. First off, let's take a step back. Forget about Java. What is 9 divided by 4? It's 2.25. It's 2 with a remainder of 1, and 1 over 4 is 0.25. So it's actually 4.2 or 2.25. Is that what Java's going to spit out here, though? Yes. 9 is an integer. 4 is an integer.
Oh, it's going to use 0 because it can't do doubles.
Yeah. Well, it can't. It's going to do integer division. So when I execute this, 9 divided by 4, it's going to spit out a 2. And the reason it's going to do that is because it's taking 2 integers and it's dividing. So the result is also an integer. Whenever you're dividing integers, it's always going to take the floor. So even if it should round up, it still rounds down. So like if I kick this up to 11, 11 divided by 4 is 2.75. But it doesn't round up to 3. It still kicks it down to 2. Well, there's probably not a lot of situations where you want 11 divided by 4 to be equal to 2. So there are 2 ways to make this calculate correctly. Can anybody think of one easy way to fix this code? Lucas?
Do a 0.0 at the end of it.
Which one?
I guess both. I think you only need to do one, though.
You could do one or the other or both. It really doesn't matter. As long as you change one of them to a decimal point 0, this thing will evaluate correctly to 2.75. That's the easy way to fix that problem. There is also a way in Java, and it's one of the things I want to talk about today, to temporarily change numbers. So right now, that 11 and that 4, they're both integers. Now, I can keep them an integer. I don't have to put a decimal point on there, but I can temporarily change them into a double. This is called casting. And you can cast either one of them, or you can cast both. But if I just put in parentheses here, double, in front of that 4, it's the same as writing 4.0, but after I evaluate this, 4 returns to an integer. So this just for this line of code right here, it changes 4 into a double, even though it's an integer. It's called casting. And you can see that that is indeed 2.75. So if you just want to change a number if you want to change the type just temporarily, you could do this. Put it in parentheses and change the type. It's called casting. All right. That's one of the things I want to talk about today. What else do I want to talk about today? Okay, let's see if you remember algebra. What's this going to evaluate to? 0 divided by 5. When I do that, what's it going to be? 0 divided by anything is indeed 0. What if I do it the other way? What's going to happen if I try to do 5 divided by 0? What kind of error do you think it's going to be? What it says is arithmetic exception, divide by 0. So the problem is anything divided by 0 is undefined. And we can talk about things being undefined like from a conceptual standpoint because it's basically infinity. But the computer doesn't understand the concept of infinity. The computer has a limited amount of memory, so it cannot calculate something that approaches infinity because it runs out of space eventually. And so it gets this divide by 0 error, and you just can't do that. So don't try and do it. You'll break your program every single time. All right, let's talk a little bit about modulus. Instead of divide, I want to do modulus here. And I want to do 5 mod 3. Anybody remember how this is going to evaluate?
It divides and then gives the remainder at the end.
So 5 divided by 3 is 1.66666666667 out forever, essentially. So what's the remainder? It's the decimal point, right? The 0.666, which is 2/3. So that means the remainder is 2. So this should evaluate, if it's just giving me the remainder, as 2. So that's what that mod does. 5 mod 2 is 2. It's just giving you the remainder. This kind of works funny sometimes. Like if I change this to 5.2 mod 3, it's kind of a weird thing to think about. So it's like 5.2 divided by 3, what's the remainder? What do you think it's going to spit out for the remainder here?
2.2.
Yeah, it really is that simple. You just add 0.2 to the remainder, and it evaluates as 2.2. So typically when we're talking about remainders, when we're doing like long division and stuff, we don't talk about a remainder with a decimal. It's kind of like counterintuitive, but Java can handle that, and that's what it'll do. All right, now I want to talk about 2 things, and that's the order of operations for Java. It's known as precedence. Then I want to teach you some shortcuts. So let me pull that up here. So I don't usually ask you to write anything down, and I won't ask you to write this down either, because I've got it posted in Schoology. But if you were going to jot something down, this is kind of important. This talks about the way that Java thinks. In what order does Java think? So whenever you're trying to evaluate something, the first thing it's going to do is whatever's in the parentheses. That's the same as PEMDAS, right? P is parentheses. It's going to do that first. But then it gets a little bit different than PEMDAS, because then we have this exclamation sign, this plus plus, and this minus minus. Each of those means something. An exclamation mark in Java means not. So it's looking for a not first. We'll talk about these logical operators some more in a couple of units. But for now, just know that if you see an exclamation mark, it simply means the word not. This plus plus and minus minus, we'll talk about that in just a moment here, does something very specific in Java. Of course, you know, multiply and divide, that's your PEMDAS, that's the M and the D, and then it does modulus as well. So if you got the mod in there, it's going to evaluate, it's basically the same as multiply or divide. Then you got your plus and minus, and then we've got a whole bunch of shortcuts here. We're going to talk about these shortcuts. That's like second to last, and then the last thing that Java looks for, the very last thing that Java looks for is a comma. It's just something that you kind of need to know. Yes, Lucas.
With modulus, whenever you have like say 5 modulus 3 and then times 3, does it multiply the remainder?
Let's check it. I think it would. So it's 5 mod 3 times 3. So that would be 9, right? 5 mod 3 times 3. Or sorry, it would be 6 because 5 mod 3 is 2. 2 times 3 is 6. Let's see if it is. Yes. Yeah, so that works exactly how you think it would. All right, good question. So let's talk about shortcuts for a second here. And it's not going to be very long here. So I'm going to declare a variable here. And it's going to be an integer. I'm going to say this integer, just call it num, equals 10. Now, if I wanted to increase that by 10, an easy way to do that would be num equals num plus 10. Right? And then I can print it out. And so what's gonna print out right now when I run this code? What is it? 20. Now that's all well and good, but computer programs are all about efficiency. And typing num equals num plus 10 is a lot of extra characters that you don't have to type. A faster way you could do that is, and I'm just going to comment that out for a second here, you could do num plus equals 10. And what this says is take num and increase it by 10. That's all that says. These two lines of code do the exact same thing. It's taking what it is and increasing it by 10. So when I run it now, it's still going to equal 20. So what's going to happen if I change this plus to a minus? What's it going to evaluate to now? Yeah, so that says take this variable num and subtract it by 10. So it should be 0. Now you can do it with basically any operator, including the mod. So if I do num mod equals 10, what do you think is going to happen here?
0.
I actually don't know. I haven't tried this before. Let's find out. It is 0. Because what that literally means is that num equals num mod 10. So 10 mod 10 is 0. And so it evaluates to 0. All right, so those are just a couple nice little shortcuts for you. The last thing I want to show you here is just a little bit more about casting. Because casting is an interesting thing you can do. What's pi? The way you can get Java to do pi, as some of us learned last time, is you could do math.pi like that. And I'm just going to store it in a variable. Call it pi. Math.pi with capital P, capital I. Now, what I could do is I could actually cast that. Pi is a double because it has a decimal. But if I change it, if I cast it into an int, what do you think is going to print here? Let's find out. Pi. Have to declare it. Here. I don't want to do that, though. I'm going to cheat instead. Glad I'm recording this. Everyone can see my mistakes forever. Okay, so you think it's going to cast as 3. Is that what I heard? Yeah, it's always going to be the floor. It's going to round it down. So pi, you're just going to remove the decimal. What if I wanted to square pi? What if I wanted to do pi square? Anybody have any idea how to do that?
Well, there's a long way of doing math times math.pi.
Uh-huh.
I don't.
Let's mess around with it a little bit here. All right, so I've got this double pi, and it's equal to pi. All right. If I wanted to square it, there's 2 ways to do that. You could do pi times pi. Should be like 10 something, I think. Almost 10. Oh, I forgot that one. We'll get that one in a second here. Glad you reminded me. Or the other way that you could square a number is by doing math.pow. Say the number that you want to square, and then the exponent you want to use. So if you want to use the 3rd power, the 4th power, the 5th power, the 6th power, just put the exponent there. And that will also give you the same answer, the 9.869. All right, last thing I want to show you. Last little shortcut. I'm going to go back, make myself a little int here. I'm going to set it equal to 10. And what I want to do, I'm going to write this line of code here. Plus, plus. I don't know why I put I. It's num. Y'all seem like smart people. Well, most of you. I'm about to print out the variable num. What do you think it's going to print out right now?
11.
Why do you think it's 11?
I don't know.
Your intuition is very good, because when I print this out, it is indeed 11.
Wow. Nice.
Plus plus is just a little shorthand. If you ever, and this will be very helpful when we start getting into for loops and while loops in a couple of units here. That plus plus just kicks it up by 1. What do you think minus minus does? Minus minus will just, instead of add 1, it's going to subtract 1, kick it down to 9. Okay? So that's a little bit of shorthand there. So these are a lot of just little shorthand things you can do with math. Now, how do you actually use it? Now I want to actually write a little program here, okay? To show you how to use some of these math things. And here's what I want the program to do. And it's going to build on what we did last class. So this program is going to ask the person sitting behind the keyboard, hey, I've got a program here. It can calculate the circumference of a circle or the area of a circle. Which would you like to do? And they'll say circumference or they'll say area. I say, great. And based on their answer, I want to calculate the circumference and the area. In order to find the circumference and the area of a circle, what do I need to know about the circle? The radius. So circumference is, how do you find the circumference? 2 times pi times the radius. And how do you find the area? Pi times the radius squared. So let's write a real quick program here and see if we can make a little calculator that can do this. So I'm going to do this through BlueJ. And whenever you get in BlueJ, just make sure everything's already closed out. So if you have I don't have anything open, but if you do, just go here to project and just close it. I don't have anything open, so I'm going to make a new one. So this is third period, so I'm going to put it in my third period folder. And I'm going to call this thing Circle Calculator. All right, and that's what I'll call the project too. If I could spell it, Circle Calculator. Guess what I'm going to call the class? Circle Calculator. Boy, I'm creative today. Okay, great. So when you create a class in BlueJ, and I'm going to encourage you to use BlueJ. You don't have to, but I'm going to encourage you to. Whenever you do it, it's going to give you like these diagonal lines here. It just means that this program has not been compiled yet because we haven't written any code yet. So right-click on it to open the editor, and you're just going to want to delete all the stuff that's already in here. At least that's what I do. All right, so I usually put my name and the period, and you could put a little description in here too. This program finds the circumference, that's a hard word to spell, and area of a circle. Okay. So every class, every program must have a main method. How do I write the main method? Public static void main string args. Yeah. Args. No semicolon. Open bracket. Curly brace. Do not put a semicolon there. Do not. Now, I'm going to ask the user a question. I'm going to say, hey, and don't feel like you need to write this down. I've got all this code up on Schoology as well. I want to know if you want me to calculate circumference or if you want me to calculate area. So in order to do that, I have to use that scanner class. Now, remember, that's not part of default Java, so we got to import it. We say import java.util. You can either type scanner to get it, or you can put a little asterisk right there. Either way will get you where you need to be. So I'm just going to use the scanner class because I don't need anything else. If you use the asterisk, it's going to bring a whole bunch of other stuff as well. All right, so I've got it. And now, let me just give myself some room. I'm going to write the program. So the first thing I ought to do is probably just ask the question, right? What is it that you want to accomplish? What are you looking to do? So let's do system.out.println. And let's just keep it simple and say circumference or area. Actually, let's do type 1 for circumference or 2 for area. Give them a command. And so they're gonna type in an answer, right? What are the two things? What are the kinds of things that they might type in here? You do a 1, 2. What kind of thing are we talking about here? Integers, right? So we want to just store that value into an integer. In order to do that, I have to create my scanner first. So we talked about this last class. I usually call mine keyboard or KB. Say, okay, I'm making this scanner. I'm going to call it KB. And what I want it to be is a new scanner with information coming into the system. All right, that creates the object. It's the first object I ever taught you. We'll do some more a couple weeks here. And now that I have that object, I can use it. I can say, okay, they're going to make a choice. So let's call this variable choice. It's going to be coming from the keyboard. And what is it going to be? It's going to be the very next integer that's typed in. All right? So we've got this integer stored called choice. They've made their choice. What might they have typed in? 1 or 2? Could they have typed anything else?
Yeah.
What else could they have typed in?
Circumference.
Like typed in the word circumference, they could type in a 7. Let's assume for now, to not complicate any things, that they're going to type in an integer of some sort. If they see I've declared an integer here, there's a way to get around that if they type in like a word. I don't want to overcomplicate things right now. So let's just assume that the person can read instructions here, and they're going to type in a number. Okay? And they're not going to break the program. So they type in a number. What number might they have typed in? 1. So I'm going to make an if statement here. Say if choice is equal to 1. Now remember, in Java, that when you are declaring a variable, use 1 equal sign to make a variable, 2 equal signs when you're doing a comparison. So I'm checking to see if choice is the same as the number 1. And if it is, we're going to find the circumference, right? So what should I do? What do I need to know if I'm going to do circumference?
Ask for the radius.
I need to know the radius of the circle, right? That's how I'm going to calculate it. So let's ask for it. Print line, say, what is the radius? Oops. And they're going to type something in, right? What might they type in?
A double.
They could do a double. They could do an integer. They could type in like a 3. They could type in a 27.4. So to be safe, should I make a variable that's an int or a double?
Double.
Okay. You are correct. It's going to be called the radius, right? And it's going to be the next double that's typed in. So I'll do kb.next double. All right? What should I do with this radius?
You can then do another one called like circumference, and then you can do the math for it. So you can do 2 times math pi r.
We could do it that way. We can make another variable, or I could actually do it within the print statement here. And either way is fine. I've seen it both ways. So you could make another variable here, call it double circumference equals 2 times pi, which is math.pi, times the radius. And that would work. And you'd say the circumference is, and you would just type it right there. And that would be perfectly acceptable. Or you could say, I don't really need that variable. And you could just take this calculation. Oops. Take this calculation here. And you can actually just put it in parentheses right here in the print statement. So either way is effective. Either way works. It's just a matter of preference, whichever you like. So you can either make a variable and then print the variable, or you could just do it if you don't really feel like you need to store the circumference. Like if you wanted to store the circumference, then you should. But if you feel like, I probably don't need to store it, you could just do it right here. This is a good place to stop and make sure the program's actually working the way we intend it. You should always try to debug your program as you go. And the way you do that is after you get to a good stopping point, you try to compile it and do it. So I just tried to compile it, and it found a whole bunch of errors. So what did I screw up? Now I get to go through here and try to figure out what I did wrong. I didn't like the name of it for some reason. But it's my, didn't like these comments for some reason. Still doesn't like it. Sure glad I'm recording this. Oh, I appear to be missing
I don't think you're missing one of these.
an extra one at the bottom there. Not bad. Yeah. Nice thing about BlueJ is it will tell you when you've done messed up. All right, let's run it. I'm almost done here now. So let's assume they type in a 1 for circumference. The radius, let's just assume it's, what is it? All right, 12 times pi times 2. So 24 times pi, so 24 times 3.
72.
Yeah. Looks like it's working, 75. Looks like it's working. All right, looks like it's working. We were close enough. Now, choice 1 is working. What if they don't type in a 1? What might they type in? Okay, so I'm just going to copy all this. And now I'm going to paste it. Instead of doing if, I'm going to do else if. And this is going to be if they put in a 2. Well, I still need to know the radius, right? But now I'm not finding the circumference. I'm finding the area. And how am I going to calculate the area? Pi r squared. So I can do that 2 ways. I could do math.pi times radius. Or I could do,
You have an extra.
it was really important. I thought it deserved to be there twice. So you could do radius times radius, or you could do math.pow, radius comma 2. Either way will get you there. Either way is fine. Let's just run it. Oh, no.
I think you need parentheses around the math.
I sure do. So let's run it, make sure it's working. Type in a 2 for area. What's the radius? I don't know, 3. 3 squared is 9. 9 times 3 is 27. So yeah, looks like it's working. Yes, Lucas.
So we haven't gotten to loops yet, but what if you wanted to loop the program and then switch from like area to circumference to area? Because the fact that a radius is already saved, would that like mess it up or no?
No, because I'm saving it here. We'll overwrite it every single time. Now, they could type in a 1 or a 2. What else could they type in?
Anything else?
They could type in any other integer, right? And if that happens, they shouldn't have typed it in. So what should we tell them? Try again. Invalid entry or something like that. Tell them they done messed up. Now, you just asked me an interesting question. What if I wanted to make this, because right now, when I compile this thing and I run it, it's going to run exactly 1 time. If I type in a 5, it's going to end the program. Well, it sure be nice if I screwed it up if I didn't have to run the program again, right? So you can get around that by making yourself what's called a while loop. And while loops are way above what we're doing right now. But I'm teaching, yeah, I am good. So instead of doing the choice and initializing the choice down here, I'm actually going to do it right here. I'm just going to set it equal to 1. And what you could say is while that choice is equal to 1 or 2, I'm just going to loop this thing. I'm going to do loop-de-loop-de-loop. Let me just kick all this stuff over a little bit. So what I did, as I said, okay, choice is equal to 1. All right. And so while choice is equal to 1, and these two straight up and down bars, that means or. While choice is equal to 1 or 2, this program is just going to run and run and run and run and run. The way that it's going to stop running is if choice is not equal to 1 or 2. So what we could do is say, add a little print statement here. Any other number to end the program. Okay, so let's try it. So give me a number. 2. Tell me the radius. All right. Now it's going to repeat, but see what happened here? Now the program's like right on top of itself, so maybe we add a little bit extra space in there so like it doesn't print right on top of itself. So give me another number. 26 is going to end the program. Instead of saying invalid entry, I should probably put like goodbye in there or something. Goodbye. Done. Yes.
Is there any way you can make it loop even if someone puts in like an invalid entry, like if they just made a typo or something?
Yeah.
Oh, yeah, that's what I was gonna ask. Is there a sign for like, well, it's not equal 1 or 2?
Say it again.
Like, is there a symbol for like, if like choice equals 1, is there a choice for if choice does not equal 1?
Yeah, it's that exclamation mark means not. Yeah, you do not equals to 1 like that. The answer to both your questions is yes, but this video is already like 25 minutes long and I want to stop it. So we're going to say this is done now. So I'm going to hit this button.